Hey everyone, today we'll be doing another Leetcode problem. Problem number 108, convert sorted array to binary search tree. This is an easy problem and given a number of array nums where the elements are sorted in ascending order, convert it into height balanced binary tree. What is the height balance binary tree? Height balance binary tree is a binary tree in which the depth of the two subtrees of every node never differs more than one. For example, here we do not have a binary height tree example. So, for example, we do not have a node here. There is no 5. This is a height balanced binary tree because the difference in the height from the left node and the right node, left subtree, you can say, is 1. But what if we do not have a total right, like no 9 and no 5? Then this is not a height balance. This is not balanced at all. This is height balanced. And now let's see our main uh, problem. Our problem is we have given a number of arrays like this: minus 10, minus 3, 0, 5 and 9. This is sorted, which is great help in this case. So we have to make a binary search tree. What is a binary search tree? Binary search tree is a tree in which the root node have the less values, the values less than 8 to the left and greater than 8 to the right. Okay, so now we will see that minus 3 is less than 0, it will go to the left, and minus 10 is less than minus 3 itself, it will go to the left. And here we can see 9 was greater than 0, we will put it on the right, and 5 is less than 9, we will put it to the left. Okay, if this was if we have to convert a binary sorted array into a binary tree, simply we will just make nodes and put values, but this is a binary search tree. We have to put values accordingly, like the less value go to the left and the greater value go to the right. Okay, so we have a sorted array, luckily for us. So whenever we have a sorted array, we have to keep in mind that the first thing should come to the mind, or this is a trick you can say, that if is there a way we can apply a binary search method, like making the pointer to the left and the pointer to the right. Okay, yeah, we can do that. In this case we will make a pointer to the left. Let me write it down to make it more simple. And but we have minus 3, and after we have minus 0 and 5, and after that we have 9. So we'll be making a pointer to the left like this, left pointer and right pointer. Okay, we'll be taking the midpoint. Okay, the midpoint in this case will be 0. We will make 0 as our root, so 0 now is our root. And after that we will move our right pointer here, the midpoint minus 1, because we already checked our midpoint. Okay, so our base condition will be, we will go if we will stop if the left become greater than the right. uh, Here it has the value of 1 and r has a value of 2. So we'll be taking the midpoint again, we will put 3 and then we'll put 1. The pointer will move itself to here again and again, and now again if we call recursively, we will be doing all of this process recursively. If we made another call, right, will go out of bounds like minus 1, which will make uh, uh, left greater than right, and the loop will stop. Okay, now we will be doing this for the right side also. Like here we have already taken our what you can say a root, and we now have 3 in here and 10 in here, 10 in here you can say, and like this, if it makes sense to see that. And after that we will go to the right, and the left will be likewise mid plus 1. So we will be comparing these two and then adding 9 and 5, 9 and 5, and just like that you get the idea. And if you keep incrementing the left again and again, it will go out of bounds, and it will sometime in the future will come here, which will just satisfy our condition to stop the loop, which was left right left if the left becomes greater than right, then we will stop. Okay, so this was it. The array was sorted, which was a big help. So we'll be making another function which will create tree node itself. We'll be passing it left and right. Okay, now we will check our base condition. If there, no, we will not be checking your base condition because there is values at null, nums. So we will say that if left is greater than right, like I said before and explained, greater, not smaller, we will just return none. Okay, if it is not, we will calculate the midpoint like in binary search, dividing by 2. Okay, this is how you divide. um, for integer, if you do it for float, you can just say like this, but we want an integer, we do not want point values, so we're doing it by this. And after that we will make our node. To call that, we will call tree node, which is like this. You can say here our class and tree node. Let me write it node nod. Okay, passing it nums and mid, which will be 0. After that we will take root in left, calling the function recursively, create tree on, no, create tree node, not node. Okay, okay, now we will be passing it left, nothing to change, but we will be changing right, mid minus 1. Doing the same with the right. Like in binary search, you get the idea how we do things. We have done like 12 to 13 problems just on based on binary search till now. And we will be passing from the left, we will be passing mid plus 1, and on the right will stay there. After this we will just return the root, and in the main function we will call this method create tree node, and passing it 0 as our left pointer, and right pointer will be length of nums minus 1. And this was our whole code. And let's see if there are any errors in this code. There are no errors, and let's submit it. Yes, that's pretty much it.